Okay, so just a small reminder before we begin of the need for you to set up a team, even a small one, to start from the labs for next week. So there are a number of students that already created a small team to work, and it's okay, but we see that I have more than 200 people. We still haven't gone through this procedure. Okay, so just remember when you make up your mind with your friends in the Telegram group, in the pin message, you have also the link for the GitHub Classroom, so that you don't mix up. So that some students use the link for the Italian version and so on. So this is the link. So actually, I try to keep all the basic information updated, so that you can start working from next Friday. Okay, on the exercise. We will give you more information about how to organize the work next Tuesday. Okay, next class. That's just for reminding. Today and Tuesday, basically, we are going to see together the the pillars of JavaScript as a language, which are arrays, objects, and functions. Well, arrays, objects, functions, and functions, because actually the behavior and the role of function in JavaScript is very, very strong and very high. Arrays are, last week we did some small exercise with strings where there were actually nothing new on that, nothing special. Arrays, on the other hand, are quite rich data structures. So it's not just a C-like array with some memory locations in a row, but it's a data structure that can be actually used in many different ways. Okay, the syntax is quite normal. It's quite as you expect. We index the elements of an array with square brackets, and every array is able to track its own length. So it's a dynamic data structure. And there are several methods, really, several pages of possible methods that work on arrays. And we should always be careful about which method, since, okay, arrays is an array is a mutable data structure, so you can actually add or modify elements or delete them or resort them once the array has been created, okay? And so we still need to be careful between methods that modify the array and methods that compute and return a new array. And this difference will be more and more important as we go into functional programming, okay? Where we really need to be careful to return new values every time because modifying function parameters doesn't work. So in many cases there are actually different versions of methods that have the same effect, but in one case they modify data structure, in the other case they return one. So from the syntax point of view, it's quite easy. For creating a new array, you just create with the square brackets an empty array or an array with a list of elements. So it's very similar if you are for maybe the most similar data structure are Python lists, so very dynamic. You can create them, you can put everything inside, or can also mix different data types. So you don't need to declare the length, you don't need to declare the data type, it's just a container, okay? A container of a sequential container, so where all the elements are indexed from 0 to the length -1, of course. So if you add something at the end, or you have add something in between, the elements are always indexed from 0 to length -1, and there are no holes inside. You cannot have an empty slot. There are other ways. For example, this is a static constructor of the array object for building the same kind of data structure. There are alternative writings for the same results, but actually we tend to use the simple one. Okay, so this is just for creating a new array. Forget about the variable v where we are assigning the content. Actually, every time you see an open square bracket, it means that you are creating a new array. Then you can do whatever you want. You can use it, you can assign it to a variable, you can use it to initialize a variable. That's another story. Let v assumes that this variable v can be changed, is mutable, is not a const. Actually, again, if I declared this variable as a const, that would not prevent me from modifying the content of the array. Okay, even if here I add a const v, I could also add elements to the array. I could use all the methods that modify the array, because the array object would be still there. You see the picture here, we have a variable that points to an array. The variable may be const, and if the variable declares const, we cannot modify this error here. Okay, the variable will always be bound to this yellow object, but the object itself can be modified. We cannot redirect v to somewhere else and reassign the variable somewhere else. So again, most of the cases, these examples we let could also work with a const. Like in this case, we are assigning some elements into an array. We create an empty array and we assign some positions inside, which looks quite strange because we are assigning a value to a position that doesn't exist yet. So it's not good practice, but just to understand how it works. And in this case, JavaScript will automatically adjust the length, create the elements as we go. Usually, we tend not to do this because actually we would need to know exactly at which position we create new values. We tend to use the push method. Actually means adding a new element at the end of the array. Okay, it's simpler and it's less error prone because we don't need to care about what is the position number. It just creates a new position. So this is normal. The version in the right hand side is the one that we are normally using, and it's equivalent to the previous one. So you see that in this case we created an array which was initially an empty box with 0 elements, and then without modifying the variable, we are adding elements, modifying the contents of the array container object itself. Okay, that's quite, let's say, normal. And for basic handling of adding and removing elements, we have these 4 methods that work on both sides of the array. So push adds a new element at the tail, at the end of the array. Pop removes the last element and returns it to reference, of course. And on the left-hand side, so from the 0 side, we also have shift and unshift that allows us to add a new element at the beginning or remove the top element, the first element of the array. So actually, with these 4 basic methods, we can use array as lists, as FIFO lists, as stacks, as queues. So all sort of a sequential data structure we can, first in, first out, last in, first out, and so on, can be just implemented with this method. So we don't need other data structures for doing that. We could question the efficiency of using a sequential array for pushing at the beginning or extracting from the beginning, because that, of course, will would imply a shift of the elements. So actually, ON complexity is not a constant time operation, but actually, an array just contains references to objects, doesn't contain the objects themselves. So actually, even if you have quite a large array, you are just basically shifting the starting address of the arrays of the memory block itself. So the implementation of JavaScript libraries is more efficient than we could imagine from just writing the code. Okay, so my thought is trust the interpreter. Okay, It's not just like many compiled languages where you actually execute what you're saying. The JavaScript interpreter is doing a lot of optimizations, and so it's less, say, less of a problem if you use this kind of data structure. We visualize it as an array, okay, as a sequential set of cells, but we don't know how it's really implemented inside. Maybe it's more efficient than that, okay? So we'll use freely this kind of method if you want to create a FIFO, a list, for example, without needing to implement your own linking mechanism and so on. Okay, so just to make a parallel, if in Java you had to choose between using an array list or a linked list, depending on the usage you do, here we just use an array and let the compiler do the optimization. Okay. Arrays are objects, but variables are references. Okay. So it means that we could assign a reference to an array to another variable, like here. And what we are doing, we are creating an alias. We are creating another reference to the same object. So this operation, if v is an array, alias equal to v does not copy the array. It just copies the reference. So at this point, alias and v, there are two references that point to the same object. Okay? Like in most object-oriented programming languages, when we have a difference between references and values, or pointers and memory objects. So just be aware that if we modify maybe a cell of the array through the alias, okay, also the real array will be modified, or the original array will be modified, so we are actually modifying the same object. So let's always be careful. When assigning a variable, we just copy the reference. Okay? If we need to create a copy of the array, of the element, so that it can be manipulated independently from the first one, we should use different methods. Like, for example, there's a constructor, array.from. In one of the previous slides, we saw the constructor array.of, okay, that took some sparse elements and put them into a new array. Another constructor with a static method from takes one existing array and creates a new array by copying the elements inside. This is one of the syntaxes for creating a copy of an array. It's not the one that we will use normally. Just in a second we'll see a shorter way of doing that, okay, a more idiomatic way of doing that. But the idea is that always be clear in your mind whether you have the v original variable, whether you're making an alias, so a new reference to the same object, and you can pass this alias around, or you're creating a new independent variable with pointing to a new independent object. So from this, and this object will copy the content from the first object, and then from this moment, this container will be independent from the previous one. Be aware just that, where is that? Sorry. No, I didn't have the picture. Okay, so I imagine you had the picture, but it was in a different place. This kind of copy is a shallow copy only. So actually, in this case, the contents of this array are the string and the number, and they are both immutable data types, so we don't care. But if the first or second element of the array would be an object or would be an array by themselves, so some mutable object or some complex object, what we are doing is to create a new array with the references to the old object, and not copying all the way down. And maybe we can see that with a small example. No, okay, for example, if I have let's use const so that it's clear, an array, and I have my maybe lucky numbers. So my lucky numbers maybe 3 is a lucky number, and I don't know, 17 is a lucky number, or whatever. I have an array of these, and I can add to V some informations like maybe my name and my lucky numbers. For example, okay? And what I get actually is, let's stop here for a moment. After this first push, I have an array V that contains one element indexed by 0 with a string. And then on the side, we have this other array, lucky, that contains some lucky numbers. I can push, so add to V this array. So I will have an array in the first element will be a string, the second element will be another array, a nested array. Okay, so I'm not adding the element, I'm adding the array object itself, and it's like this. Okay, so first element is a string, second element is an array. So actually now V index 1 is the same object as lucky. So two ways of accessing the same object, this array. Okay. So what happens when we make a copy? So if we add new statement like v2 equal to v, we understand what happens. So we create a new copy, or const v3 trying to copy the value, so array from V. Okay, so there are two ways. One, we are copying the reference to an array, and the other, we are creating a copy of the array. What happens here is that, let's go to this, sorry. Okay, this is what we had before. In the first case, we are creating a new reference to an existing array. So I expect to see a v2 here somewhere that will point exactly to this first yellow block. And this is what happens. Okay, so I didn't create any, I didn't copy anything, okay? I just duplicated the reference. In the second case, the slides tell us that we are creating a copy of the array. So I expect to see another yellow box, another array, somewhere here, with the same value, copied over. So copy the string means having another string. Copying these objects, the object, means copying the reference to that object, okay? Shallow copy. So in this case, we have two independent arrays called V and V3. They contain in the first position a string, actually two different strings. Well, we don't see it in this picture, in this representation, but actually it would be the same string objects with two different references pointing to it. We don't care about this because strings are immutable, so we don't care whether they are the same object or two identical objects. Okay, so but in the second element, it's very clear that we did copy the value of v1 into v3 index 1. We copied the value, but what was inside the cell was a reference to an object. So we copied the reference. That object is shared, okay? So now it has three different aliases from which it can be accessed and it can be modified. Okay, so it's quite normal, okay, in the object-oriented memory management paradigm, but just I find it useful to visualize also what is happening behind the instruction. And by the way, I told you there's a simple syntax for doing the same thing, and it's this one. Normally, when we create a copy of an array or an object, we'll see the idiomatic way of doing that in JavaScript is by using this trend syntax. That, of course, gives you exactly the same result. we are basically combining two operators. One is the square brackets, saying create a new array. And create a new array expects the list of elements inside. And the in JavaScript it's called the spread operator, takes a collection and converts that into a inline list of its elements. So we are taking the list V, we are unpacking all the elements, so just imagine putting inside the brackets all the elements taken from V, separated by a comma, and then recreating a new array, square brackets, using those elements. So it's a simple way, and I think it's visually also much easier to remember than array.whatever method, the static method you need. Okay, and we'll use a lot this kind of strange operators to make things easier. Okay, and I think it also helped me a lot visually, because I see a square bracket, and so in my mind it's always linked to that's a new independent array. Because I'm creating a new one. Just trying to bury some connection between the syntax and the mental model of the data structure. What can we do with arrays? Well, we can iterate over them with the for statement, and we already mentioned last time there's a for of construct, not to be confused with for in, that we don't want to use. But especially when we deal with arrays, we will mostly use functional methods. Okay, so implicit iteration managed by some functional methods. We don't see them today because we first need to study a bit how the functions are working and higher order functions, but we'll come to that. And that will be initially, we tend, or maybe we would think of using arrays in a C-like manner by iterating and doing something element by element, but we will unlearn this quickly, and we will learn how to deal with them with functional methods, which is more flexible and can be combined. So let's try to move some habits away. And as I mentioned, arrays are quite powerful data structures. These are some basic methods. For example, the concatenation of two arrays that maybe can also be done with the addition sign, with the plus sign. Join joins all the elements of an array into a new string. So if an array.join comma, it will create a comma separated list of the elements. Let's see, for example, here, if I have a string like v.join with a comma, or a semicolon, for example. And what happens here, you see that it creates some strange representation of my string, semicolon, and you see 3,17. Actually, what did it do? It took this string, this array, and took the first element, and just it copied there. Then it stuck the separator, semicolon, and then it took the second element, that was an array, and tried to convert this array into a string, and then concatenate that into a string. So this 3,17 is a comma, not a dot. Okay, it's not 3.17, but it's 3,17. It's the string representation of the array. Again, what we had as implicit conversions are working. An array, we need a string to concatenate, so the array is converted to a string. How is the array formatted into a string? Well, JavaScript decides. In this case, it puts a comment on that. Okay. We may be happy with automatic conversions, or we may maybe want our own, and so in that case we would first convert the string to the array to a string, and so on. So just be aware that, for example, joining the elements of an array doesn't require all of them to be strings at the beginning. it will convert them on the go. Maybe it's what you want, maybe it isn't. So the conversion to string is always behind the corner in JavaScript. Always think about the data that you're having. Okay. Slice extracts a section of an array and returns a new array. You see that new is in boldface because it tells us that this method doesn't modify the existing array, but just create and return a new one. Okay? Okay, slice is just a subsequence of the array, taking some elements from a beginning to an end. And then there is this powerful method, which is dangerously similar in name to slice, which is called splice. It's dangerously similar because it's very different. First of all, splice modifies the array in place. So it doesn't create a new array. So the method itself returns undefined, doesn't return any value. In JavaScript, it's impossible not to return any value, but there's always a return value, which in this case is undefined. And it combines the deletion and the addition of new elements inside an array. So actually what splice does, it takes an index location, the first parameter, it deletes some elements, 0 or more, from that location onwards, and in place of this element, it will insert other elements that you're listing at the end here. So it find a location, find a range of elements starting from this location, and remove those and put something else, which may be shorter, may be longer. So it works as an element for removing one element, index 0, nothing more. For removing a group of elements, index, position, 3, nothing more, don't add anything. Or for adding something in a position, so position I, index, 0 to remove, and then some element to add. So we are inserting something in the middle of an array, or combining all the three. You can replace an element or a set of elements if the count to remove is equal to the number of elements, so the total length will not change, or it can shorten, it can lengthen. So it's quite a single method with many different usages. Can be, of course, it can be confusing, but at the same time, it can be useful. It modifies the array, okay? Just be aware that this is an in-place modification. But, well, reverse also creates transposes the element in an array in place, so it will just reverse the element, what the first element becomes the last, and so on. Not very useful. Sort is useful, but we must be careful. Sorts the element of an array in place. Sorting the elements of an array means comparing pairwise each couple of elements. And how these comparisons go? Oh, if we have different data types into an array, comparisons will basically always try to convert to strings and then do string comparison. And this is a pitfall. For example, 317, lucky, okay? If you do lucky.sort, let's add another one, maybe 5. And here, 24, whatever. Sorry, that's an extra comma. And let's see what is happening when I sort. So this modifies the array, so it doesn't need to return anything. Not now. And okay, this is the before the sorting 5, 3, 24, 17, what we had, and afterwards we have 17, 24, 3, 5, which is surprising because these are numbers that they put in. They are not strings, but they have been sorted like strings. So just remember that sort by default sorts everything as a list, as an array of strings. Even if you have numbers, they are converted to strings, which is stupid because they already were numbers, but it's the basic behavior. We'll see how to pass a comparison function as a second parameter to use our own sorting criteria. Okay? But this is a common mistake, thinking that if I have an array of numbers, I can sort it by increasing values of these numbers. No, they don't. Okay? Sort always works as a string. Well, there are then search functions, search methods, sorry, finding the index of an element. So it finds the first or the last occurrence of a string if, of course, the element is present. And if you just want to check whether an element is contained or not without caring about the position, we have includes also that finds a value and tells you true or false whether the element is inside or not. So basically the basic operations on arrays in a generalized way with some warning. Okay? And especially just be careful about new array or existing array. Then, of course, if you go to the documentation, you find a lot more methods and functions, but I think these are the ones that to begin with. Yes?
Is there a method to find all of the index of an element?
Finding all the indexes of an element, you can just loop over this, or use the filter function. So it's in functional programming, you just use a filter that returns a new array with matching a given condition. So that would be the normal way of doing that. Okay, from the syntax point of view, there are some shortcuts. For example, I can create an array like this, okay, like we saw, but we can also see an array-like syntax on the left-hand side of an assignment. So this is also called a destructuring assignment. So I have an object, it's an array. When I'm assigning these objects, I'm not assigning it just as a single object to a single variable to make a reference. But I'm destructuring the object, so I'm putting its pieces apart, and assigning the different pieces to different variables. Okay, and how to destructure and assign them is just we have the syntax on the left-hand side that mimics the shape of the object that we are copying. Okay, so let square bracket xy means, okay, I'm expecting to have an object of that array with two elements. The first one will be assigned to a new variable, because let we are creating new variable called x, and the second one will be assigned to a new variable called y. And if we have more than two elements, the others will not be assigned. Okay? This shortcut is useful when you are maybe a function that wants to return many values. You just return an array, and then when you receive the array on the other side, on the function caller, you just extract the different items. You don't need to create an object with all the fields and so on like you would do in a more strongly typed language. So arrays can also be volatile containers, so we just put something together because we want to transfer it as a single value, and then we destructure it and separate the pieces. Well, this can be also as a shortcut for swapping two variables, because we are creating an array with the elements in some way, and then we are assigning to this variable. In this case, there will be existing variables with the same values but in the reverse order. So again, a shortcut. And as I say, okay, they can be also used when calling some function. There's a lot of syntactic sugar in JavaScript, and sometimes may create strange constructs. Like I said, we have these spread operators that can be used in different contexts. So on the right-hand side, so in an expression, on the value part of an assignment expression, it decomposes and extracts the element of a structure and treats them individually. On the left-hand side, it will pack the elements into one single data structure. So actually what we are doing here is we have an array of 4 elements, and we are copying them into the first one into X, and all the others as a single value, so as an array value, into Y. So Y in this case will be an array that collects the element. So the operator is the same, but usually we call it collect on the left-hand side and spread on the right-hand side, just because it works, of course, in reverse. Can be useful, for example, you know, other languages have special syntaxes for functions with a variable number of arguments, for example. So you have to deal with some arguments, you don't know how many they are, and this is just here. Let's collect all of them and then put them into an array. Let's process them. So there's no, the operators on arrays cater for many other syntactic structures that in other languages are necessary, and here are just ways of using arrays. So it may seem strange at the beginning, but then they're very flexible. Okay, so this is the syntax that we already saw before. That's not the most frequent way I would use to copy a value. Okay, so these are some basic notions about the array. Just to put them in practice, we can try to play with this simple exercise, okay? That calls us to define, it's a markdown, so it can also be shown more nicely. So imagine we are giving some scores in a Q&A website. This Q&A website is something, you can imagine something like Stack Overflow or something like that, and will be the example that we are using in the classroom for as a case study for doing the example. So we can imagine, we can also reuse some code in the next weeks. So imagine that we posted a question, and this question got a set of scores. Okay, so the scores of your question are integer numbers, so you have an array of integer numbers, and we want to define an array with all the scores that you received in chronological order. Okay, for the moment we don't have any input-output knowledge yet. You don't know how to read this information from a file or from the input or from a database, and so we just embed the scores in the code. No? So this means that we create a new file, scores.mjs, and define, let me make a bit larger, scores what's the specification? The specification tells us that scores are integer numbers and they may be negative. Okay, so maybe the first score I got was -2, and then I got a 5, then 2, -1, -3 because I have a lot of friends, 4, 4, 2, another 5, which is my sister, who gave me the top score. So just in the way they are received, let's say in chronological order. So what should we do with this set of values? By the way, I say I embed the values into the code as an example because we don't have any input-output, and in JavaScript the input-output will be practically never from the user keyboard and almost never from files. Okay, because remember that JavaScript will be running in the browser, and it doesn't have the console, and it doesn't have access to the files on your computer. So actually most of the input-output will be on the server side by interacting with the database, and what we'll see soon, or on the client side interacting with the network, or with the browser to get some information. Okay, so the standard input-output methods like keyboard and files are practically never used. We use APIs for database on the server side. We do API for the user interface, for the browser. We use APIs for the network connection between, to get data from the server and so on, or to call remote APIs. And these will be the methods for doing input-output. And that's why we will never learn even how to do a console input, because we don't need it. Sorry. Okay, what should we do? Okay, of course there will be many other information related to some score that you got. So for example, what is the question that got the score, and who was the author, and which were the answers? We don't care for the moment. We will create, this means that we need to create a small database that stores this information. But for the moment, we only have arrays as a data structure, so we ignore all the rest. So what should we do? Duplicate the array, so create a new copy of scores. The exercise was called better scores. Okay, we are trying to cheat. Okay, and say, okay, we got some scores, but I will show you this one, which are like we do with the scores of the exams. Okay, when you go home, you tell the scores you got, but they always eliminate all the negative scores. Eliminate the 2 lowest ranking scores, and so we delete a given number of negative scores, n, negative, plus 2, and then we add another new scores at the end of the array with a value equal to the rounded average of the existing scores. Okay, so we take the scores. Okay, we got 10 scores, and we return another 10 which only contains the positive ones, and we fill the one that we deleted with the average, so the average of the positive doesn't change. It's just a stupid exercise. So, how to do that? In many ways, of course. We can write some instruction. We don't have functional programming yet, so we do that the old way, by iterating over elements, and then when we see a functional programming, we will revise the exercise by modifying how we work. Maybe we have too many. No, we don't have too many negative scores here. Maybe let's put something more positive somewhere so that we have a larger number. So we need to make a copy. So we need to preserve this array and make a copy. Let's call a new variable better scores, for example. And we fill this new array with only the positive values, that what we said. Okay, so we need to count how many, or copy only the positive values into this new array. So that could be something like for score of scores, if S is positive or null. Does the text say anything about 0? They may be negative, and says eliminate the negative, so it means that 0 should be kept. Probably. That's an interpretation of the text, but since that if S is greater or equal than 0, and here, of course, we are assuming that this comparison makes sense, so that S is a number, okay? We know it, okay? So JavaScript doesn't know about the data types. If S wasn't a number, then it would become a string comparison, but we know they are numbers. So if it's positive, let's put it into the better scores, for example, push the S. And probably the number n can be simply computed as the difference of the two lengths. Scores dot length minus better scores dot length. Okay, I could keep track with a counter by doing that in this for cycle, but Okay, so you see that I declared the array as a constant array, even if I'm adding elements to it, because I'm adding elements to the value and not to the variable. And let's see if it works. Let's print the value of n and of the better scores. Save and run. Yeah, that's an error. S is not defined, right? This, I need to define also the variable for the loop control. Save and run. Okay, so it's printed 3. 1, 2, 3, right? And a list of elements in the same order, but only positive ones. Let's throw a 0 inside, so that we have some more corner cases to consider. Okay. We didn't think about that, but okay, we have 0. Okay. So for debugging, we have also the possibility of seeing, okay, what happens with 0? We see it. Okay, that was first point. Creating a new array with a subset of elements that match some condition. This is what in functional programming we call a filter operation. And we see how to do that. We'll see how to do that. So a new array with the same elements, but filtered by some condition. Only a subset of the elements that match some condition. Then eliminate the 2 lowest ranking scores. We could find the minimum and delete it. Sort the elements. Sort and then remove the first 2. That's one possibility. There are 2 different possibilities. 2 lowest ranking scores means what if there are more than 2? Okay, in this case it would be 0 and 2. But these other 2, which is at the same level of the second one, should it also be deleted or not? So when we have elements that are on the same level, should they count or not? No, well, in this case, from the text, I would say, okay, it's asking me to delete exactly 2 elements. So whether they are equal or whether there are some other element which are equal to them, I will only delete one of them. In this case, we don't care because there are just numbers. But just imagine if this number would be associated with a different answer to my Stack Overflow question, and the 2 answers have the same score, which one do I delete? Deleting this, a 2 or deleting another 2 doesn't make any difference. But deleting the 2 for your answer with a 2 score or his answer with a 2 score, they make a difference to what we are doing. So let's always try to be suspicious and try to ask questions to clarify what you are trying to do. This is a simple exercise, but every time I always have new question about corner cases that we should consider. So we don't know. There are 2 ways, like you said. One way is to find the minimum and delete it twice. That's one possibility. And another is to sort the array and remove the first 2 elements. Is it easy to find the minimum or the maximum in a JavaScript array? I don't know. I don't remember. So I'm not ashamed of not remembering, because we must know and to search the documentation. So array max. Let's see if we have some method in arrays. These are all methods in array buffer. There's a math.max method. Okay, method max static method returns the largest of the numbers given as an input parameters. So it requires, and max, of course, we have also min. So this is why, as a possibility, we want to use this method for finding the minimum, and then we will delete it. It doesn't tell me, it doesn't work with arrays. You see, it works with the parameters. So it's a function, or it's a static method of the math object, by the way, but it's a function that requires many parameters, and we compute the max among all of these. Numbers. It only works with numbers, so if we need to find the lowest ranking string, it doesn't work. But in our case, it may work. Okay? So how can we do that by seeking the minimum into an array, not a list of numbers, because we don't have many single variables? Oh, we already have the example here. We take the array, we spread it over so that it looks like many numbers separated, and then compute it. So, for example, we have here, we can compute the minimum value as math.minimum of the better scores. Now we have the minimum, we should remove it. And for removing it, we must first find where it is. So we have the position of the minimum with an index. Let minimum position equal to better scores dot index of the minimum value. And we can remove it with a splice operation. Better scores, splice of the index position of the minimum, comma, now delete count 1. And console.log, better scores, we see what we did. So we remove the 0. Okay? There are 10,000 ways of doing that. Yes?
Can we not sort the array and then remove the first element?
Yeah. We'll see the other option by sorting in a row. Just of course, what we are doing here, we are navigating the arrays 3 times. Okay. Of course, minimum will need to navigate all the elements. And then I always feel bad for myself when I found the minimum and then I need to rescan the array to find its position. And then splice will always have to then rearrange the rest of the array by shifting by 1 position. So actually we are iterating 3 times over the array, while for this kind of operation we could do only in 2 passes. Who cares? Well, no. It's not that we don't care about performance, or of course we do, but because it's code that it runs on the browsers and will slow down the user experience if we do something which is not very efficient. But just compare something that can run in maybe 1 millisecond compared to maybe our code that needs to contact the server with an API when the user is typing something that will take hundreds of milliseconds. Okay, so my message is that when thinking about performance, try to identify which are the real performance bottlenecks and don't try just to optimize every corner of it. Especially if we are working with library functions and we are not looping ourselves, and they can be optimized. They are already optimized in the library. But and so for eliminating the two minimum elements, we can just repeat this twice. Okay, so for example, for let c equal to 0, c minus then 2, c++, repeat it twice. Yeah. And yes, and should work by removing. Now we see that from 8 elements we only have 6, and we remove the 0 and the 2. That's one possibility.
But we have 2 tools.
Sorry? We have 2 tools, yes. And but imagine we are, yes, we don't know which 2 has been removed. Basically, we removed the first one. The text doesn't tell us what we do when we have equally ranked questions. So maybe you have first place, and then you have, what's the name in English for people who get the same score, I don't remember. And so what to do with this case is not specified. So actually what I decided, because I'm lazy, say, okay, let's just take one of them. Otherwise, well, that would be a different algorithm. When we find the minimum value, we should, in that case, remove all the elements with that minimum value, even if at the end there will be more than 2. Okay, the alternative was sorting the array, okay? But we know that sorting is not dangerous, but we work with strings. We want to work with sort with numbers, okay? So let's see how to do that, maybe by arrays.sort. The sort method of array sorts the elements, sorry, let's make it a bit larger, and returns the reference to the same array now sorted. The default sort order is ascending, built upon converting the elements into strings, always, and then comparing their sequences. Okay, so that's not what we want. How can we do it in a different way? Well, actually, there is a second form of the method that takes as an argument a comparison function, like a comparator in Java. A function that can be used to do your own comparison. So if you pass a comparison function, this function determines the order of elements. A function that is called with 2 elements that the algorithm wants to compare, and it should return a negative or positive of 0 value. And actually, the example is said, okay, if as a function you are writing this, it will sort numbers in ascending order. Now we don't understand what the syntax is like, what it means. Let's just be dumb and copy and paste, and then when we study functions, we will understand all the real meaning of that. Okay. So what we could do as an alternative, so not this. The alternative way by sorting would be, let's say, the better scores and sort them by applying this comparison function, which is the difference within the 2 elements. Actually, this says, I'm defining an inline anonymous function that takes 2 parameters, a and b, and returns the difference between a and b, and we hope they are numbers, otherwise we wouldn't be able to do the difference. And that's good for an ascending order, So the two smallest one will be at the beginning and the largest one will be at the end. So if it's true, then we can just delete the first two elements. For example, we may shift twice, or we may splice two elements. Splice 0, 2. And at the end, it should be the same, I hope. Yes, it is. Sorry? We can also use slice, you say. Okay, using a slice, it's also a possibility. Let's see all the documentation is always my friend, okay? Slice, it takes no parameters, useless, only the start or the start of the end. And if the end is omitted, probably it will, not probably, it will run up to the end of the array. So in this case, you are saying that we can have better scores dot slice from the second to the end, like that. Okay? Just beware that this does not modify, so slice doesn't modify the array, will return a new array, so you would need to assign it to somewhere else, like that. Right? And this conflicts with probably better scores being a const. So it shouldn't run in this case. So yes, it will tell me, no, a wrong error message. It's not what I expected, so let's try to run that again. Unexpected end of input means that I have opened some brace or some, and I didn't close it usually, or what? Ah, no, sorry, it was an old message. The actual message is here, assignment to constant variable. So this works, can be done, but we should define better scores as a modifiable variable, and that, in this case, we run normally. And the difference, of course, with this method is that we are losing the original order of the questions. That's possible. Oh, by the way, we are sort of assuming, without checking, that we have at least two positive elements. If we have less than two, we run into trouble, because in the first case, this min would have the minimum of one element. Waka is not so bad, or the minimum of 0 elements creates an error, returns. The documentation says that it will return infinity, and then when so it doesn't create an exception, when we are doing an index of infinity will not be found, so minimum position will be undefined, and we try to splice over the undefined index. That will generate an error, a runtime exception. Okay, so at this point, for doing all of this, we should check whether we actually have two elements to remove. Maybe 3, because then we have to make the average of the remaining ones, and we need at least one element to make the average out of. So all of this exercise should be, if you have at least 3 positive evaluations, then you can remove 2 and do all the trick. But let's put that as a big warning. It's just a toy exercise, so we wouldn't know what to do in this case, but in a real application, of course, we would have a motivation for doing that, okay? And so we will know how to handle that. So there are many ways of doing that, and then what we want to do is to add the new scores at the end of the array with a value equal to the rounded average of the existing scores. The existing at which stage? The original or the after all the deletions? Probably after all the deletions. So the current ones. And so how to compute the average? Do we have an average function to use? No. AVG? No. No, there's nothing in the library, but we can do we have a sum function? Sum talks about a node set. I don't know what a node set is, so it's not. In fact, it's as a sum from XML. Let's take only for JavaScript. So there's no sum, and no average in JavaScript.
In
Array.sum. I don't see it. We don't care. We make it ourselves. Okay. And it's a basic function, but it's not in the standard library. Okay. So we know how to do that, of course. Let sum equal to 0, and for const score of better scores, sum is increased by s, and at the end the average equal to sum divided by the length. Making the sum from a functional point of view is an example of reducing operators. So take the whole elements of an array, do something on them, and compute a single result. Okay? And so usually we use a reduce method for doing this kind of computation. Here we are doing just the old way, like with loops. Okay? And now we need to add at the end of better scores many times this average value. Okay, let's do a loop for const c, no, sorry, we use a node style loop, so I need to make a variable c equal to 0, c minus then ns, nn plus 2, c++, and then better scores dot push average. Right? And let's save and run. We have 2, 3, 4, 4, 5, 5, and then 5 times probably, yes, 3, because we had 3 negative numbers, and 2 were the minimum that we deleted at the end of the array. Actually, the text is also asking for adding a rounded average. So what's the JavaScript for round? I don't know, or I pretend not knowing. Math.round, I could have guessed it. Return the value now, round it to the nearest integer. Okay, so you don't get to specify the number of digital decimal places. It's always to an integer. To the nearest integer, so it's close to surrounding. And so this means that we can do just math.average, math.round, and it should round to 4. and that's what it does. 1, 2, 3, 4, 5. No, there's something wrong because now we have more elements than the beginning. We had 8, and now we have 11. What's wrong here? So let's, right? Am I wrong? We have too many elements here. Oh no, we have, no, sorry, because this was not the original one. The original one was the one with negative values. Okay, so. By the way, I mentioned debugging, and for entering the debug mode, you just have to set a breakpoint somewhere, and go here with the debug, run and debug with node, and pause an exception. Okay, we need to find the right file, but okay. Sometimes it needs to run twice to understand in which directory it's called. And so we have here all the variables that will be called, and the usual control for debugging. So, for example, we have the scores that are here, and you can, of course, step by step see what is happening. You have all the variables here that, sorry, let me, I'm never able to control the mouse so finely, but okay. We have variables, you see that there are different levels in which variables are defined. Some are global variables, but we didn't define any global variable of our own. Okay, that's fine. What they call module variables, and modules basically is a file. So variable defined inside the file. And block variables, a block is something delimited by braces. So for local variables inside a loop, for example, you see that S, which is the loop variable of this for, is defined as a block level variable. It means that its lifetime starts here and ends there, ends at the end of the block containing the iteration. So outside this block, this variable will not exist anymore. When we define something for loop operations and so on, we are injecting the definition inside the body of the iteration and not outside of it. So it's also easier to avoid mixing loop variable from different fors or retaining all values from before. And so, for example, if we go forward a bit, I don't want to set another breakpoint, we'll be there soon. Yeah, you see that when we are now past this for loop, the variable s doesn't exist anymore. And so you don't have also the problem of having a leftover value which is normally outside the array that you are iterating over. This is for normal for cycles, the for of, and while the and also for normal for, you see that the C is inside the block. So this is different from other languages where this variable will exist also after the iteration. Okay, it will not exist anymore. Okay, but apart from that, we have a normal debugger where we do step watches and breakpoint and so on. We're just there. And okay. Do we have something amiss from the exercise? Probably not. Like I said, this was just a simple implementation where we are trying to work with the data structure itself and with some manual mode, let's say, and some of this operation will be, when we see the functional operations, we just reduce to one line, okay? Okay, the next topic, but I would say that it's for after the break, would be starting to check the other construct of the language, which are objects and functions. They also give a different view of the language itself, of how the language is built. The question is JavaScript object-oriented? After the break, we have the answer. Okay, so let's start again at 5 past 10, 15 minutes. Is it okay for you? Okay.